Hello, in this video we are working through section 8.8 on applications of Taylor polynomials. In day 2 we're approximating some real numbers using Taylor polynomials, and in this specific example we are going to use a Taylor polynomial of degree 2 to approximate the square root of 18, and the problem says to not round the answer because the decimal value is going to terminate with 7 decimals. Now that does assume that you choose the same function and center that the solution for this example is done, but considering what we saw in the previous example, you should be able to pick an easy function and a more accurate center, and if you follow those guidelines then you will come up with the same function and center. So we will use this Taylor's formula to find the maximum error associated with our approximation, and we're going to use the decimal exact value or the calculator exact value to figure out how accurate the approximation is. So first off, using a Taylor polynomial of degree 2, we need to come up with a function and a center that will work well here. So let's go ahead and use f of x equaling the square root of x because we are approximating the square root of 16. So keep in mind that we are going to think about x being 18. I'm sorry, I said the square root of 16 a second ago. The square root of 18. So keep in mind that we have x equals 18. The square root of 16 is an easy number to evaluate, and it's pretty close to 18. So let's use a equaling 16. Okay, so for our Taylor polynomial of degree 2, we are going to need to differentiate a couple of times. So our nth derivative of x to begin with, f of x is just the square root of x. Our first derivative is going to be 1/2 x to the negative 1/2, and f double prime of x is going to be negative 1/4 x to the negative 3/2. We're just using a power rule each time there. Next, we need to evaluate our derivative at our center A, which in this case we have chosen to be 16. So our first function, f of x, equaling the square root of x, this is going to be the square root of 16, which is simply 4. F prime of 16 is going to be 1/2 16 to the negative 1/2. That means we're going to have a square root in the denominator, so we're going to have a 1/4 here. And that times 1/2 gives us a 1/8. F double prime of 16 will have a negative 1/4. 16 to the negative 3/2. So now we have 16 to the negative 1/2, so that's going to be a 1/4 like what we saw up here, but then we are cubing it. So this would be negative 1/4 and cubed, which is going to give us, let's see, 64 there. And then of course times another 4, let me see, sorry, I am thinking of too many things. The negatives will cancel out. We'll have a 1/4 times 1/64, which is 1/216. Nope, 56. I'm really sorry. Oh, had a couple moments with my brain there. Okay, 1/256, that sounds better. Now, to finish off our table here, we need to take our nth derivative evaluated at 16 and divide by n factorial. So first off, we have f evaluated at 16 over 0 factorial. Remember, 0 factorial is just 1, so this gives us just 4. F prime of 16 over 1 factorial. Again, 1 factorial is just 1, so we just take f prime of 16, which is 1/8. So we have our 0th coefficient, our first coefficient, and f double prime of 16 divided by 2 factorial means we are going to have 1/2, the 2 coming from the 2 factorial, times 1/256, and that gives us 1/512. Whoops. I am sorry, you may have noticed this already, but that negative should not be there. Back over here, I'm not quite sure where it came from. We have 16 to the negative 1/2, which gives us the 1/4, and then cubing that will give us the 1/64. We have a negative there. So this should be negative, and that should be negative. So let me rewrite that. So what we get here is a negative 1/512, and this is our C2 coefficient. So now, putting that together, our second degree Taylor polynomial is going to be C0 plus C1 times x minus a plus C2 times x minus a squared. C0 was 4. C1 was 1/8 times x minus a was 16 plus C2 is negative 1/512. So we'll just do a subtract 1/512 and then times x minus 16 squared. So this is our second degree Taylor polynomial. We need to use this to approximate the square root of 18. So to approximate the square root of 18, remember this corresponds to x equaling 18. So the square root of 18 is equal to f of 18, which we can approximate with our polynomial value, or polynomial evaluated at 18. So that's going to be 4 plus 1/8 times 18 minus 16, or 2 if you want to write it like that to begin with, that's fine, minus 1/512 times 18 minus 16 squared, or that's 2 squared, which will equal 4. Now from here you could very easily put it into a calculator to simplify if you'd like. If you do it by hand, the fractions are possible, although they are not very pretty. 543/128, which, if we write the exact value, is 4.2421875. So this is our approximation for the square root of 18. Now, to complete this problem, I'm going to do it in a second video to keep down the length of each video. So we will pick this back up in our next video.